Our universe is a vast and ever-changing place. It's a cosmic dance of unimaginable scale where galaxies, stars, and planets are all in constant motion. From the smallest particles to the largest structures, everything is in a state of flux. It's not just sitting still, in fact, it's expanding. This expansion is one of the most fascinating aspects of our universe. Imagine the sheer scale of it all. Billions of galaxies, each containing billions of stars, all moving away from each other. Imagine a balloon with dots drawn on it. These dots represent galaxies. When the balloon is deflated, the dots are close together, but as you start to blow air into the balloon, something interesting happens. As you blow air into the balloon, the dots move farther apart. This simple analogy helps us understand the concept of cosmic expansion. Just like the dots on the balloon, galaxies in our universe are moving away from each other as space itself expands. That's kind of what's happening to our universe. The space between galaxies is stretching, causing them to drift apart. This isn't because the galaxies themselves are moving through space, but because space itself is expanding. Space itself is stretching, carrying galaxies along for the ride. This phenomenon is known as the metric expansion of space. It's a fundamental aspect of our universe, shaping its structure and evolution. We know this because we see distant galaxies moving away from us. Thanks to powerful telescopes and advanced technology, we can observe these galaxies and measure their speed and direction. The farther away they are, the faster they seem to be receding. This observation is a key piece of evidence for the expanding universe. It's known as Hubble's law, named after the astronomer Edwin Hubble who first discovered it. This expansion started with the Big Bang, the event that birthed our universe. Around 13.8 billion years ago, the universe began as a singularity, a point of infinite density and temperature. Then, in an instant, it began to expand. It's been happening ever since. Over billions of years, this expansion has shaped the cosmos, creating the vast and complex structures we see today. Galaxies formed, stars were born, and planets came into existence. But what if this expansion were to stop? It's a question that has intrigued scientists for decades. If the universe stopped expanding, the delicate balance of forces that govern its behavior would be disrupted. What would happen to the universe as we know it? Would galaxies start to collide more frequently? Would the universe eventually collapse in on itself? These are questions that continue to drive research and exploration in the field of cosmology. Imagine the universe suddenly stopped expanding. It would be a dramatic cosmic event. Everything we thought we knew about the universe's behavior would change. Instead of galaxies continuing to drift apart, their own gravity would begin to dominate. The universe would become a cosmic tug-of-war between gravity pulling things together and the inertia from the expansion trying to keep them apart. Would time be affected? It's a mind-bending question. Einstein's theory of relativity tells us that time and space are intertwined. They form a fabric called space-time. If the universe's expansion influences space-time, then its halt could have ripple effects on time itself. Would time slow down? Could it even stop altogether? These are questions that physicists are still pondering. In a static universe, gravity would become the dominant force. Without the counteracting push of expansion, gravity would relentlessly pull everything together. Stars and planets would experience a stronger gravitational pull. Black holes, with their immense gravity, would become even more powerful, potentially growing larger as they consumed more matter. Section 5. Galactic dances in a crowded cosmos. Galaxies are massive collections of stars, gas, and dust. They move through the universe, often interacting with each other. In our expanding universe, these interactions are somewhat limited, but in a static universe, galaxies would be drawn closer together by gravity. Collisions between galaxies would become more frequent. These collisions would be spectacular events, triggering bursts of star formation and potentially even merging supermassive black holes at the centers of galaxies. Section 6. Life finds a way, but how? Life as we know it depends on a stable and predictable universe. The delicate balance of forces, from gravity to electromagnetism, creates an environment where life can thrive. Our planet Earth is a prime example of this balance. It orbits the sun at just the right distance in what scientists call the Goldilocks zone, where conditions are neither too hot nor too cold for liquid water to exist. This stability has allowed life to flourish over billions of years. The expansion of the universe, while vast, is a slow and gradual process. This expansion has been happening since the Big Bang, approximately 13.8 billion years ago. As galaxies drift apart, the universe becomes more spacious, but this process is so slow that it doesn't disrupt the conditions necessary for life on planets like Earth. The gradual nature of this expansion means that life has had the time to adapt and evolve in a relatively stable environment. Life on Earth has had billions of years to evolve and adapt within this expanding cosmos. From the simplest single-celled organisms to the complex multicellular life forms we see today, evolution has been a slow and steady process. This long timeline has allowed life to develop intricate systems and adapt to changing conditions. The fossil record shows us a history of gradual change, punctuated by occasional mass extinctions, which have also played a role in shaping the diversity of life we see today. But a sudden halt to expansion would be a cosmic shock. Such an event would disrupt the delicate balance that life depends on. The forces that govern the universe, such as gravity and electromagnetism, would be thrown into chaos. This could lead to catastrophic consequences for any form of life, especially those that have evolved under stable conditions. The changes in gravity, the potential disruptions to time, and the increased radiation from galactic collisions could all pose challenges to life's survival, especially for complex life forms. These events could lead to increased levels of radiation, which can damage DNA and other essential biological molecules. Additionally, the gravitational forces from colliding galaxies could create tidal forces that would disrupt planetary orbits, making it difficult for life to maintain the stable conditions it needs to survive. In such a chaotic universe, the resilience and adaptability of life would be put to the ultimate test. Section 7. The echo of the Big Bang evidence we seek. How do we know the universe is expanding? This question has intrigued scientists for decades, leading to numerous studies and observations. The idea that the universe is expanding was first proposed by Edwin Hubble in the 1920s. He observed that galaxies are moving away from us, and the farther they are, the faster they seem to be receding. This observation was groundbreaking and laid the foundation for our current understanding of cosmology. Scientists have gathered evidence for this expansion through various observations. They use powerful telescopes to peer deep into space, collecting data on distant galaxies and cosmic phenomena. By analyzing the light from these galaxies, they can determine their speed and direction. This data has consistently shown that the universe is indeed expanding. One key piece of evidence is the cosmic microwave background radiation. Discovered in 1965 by Arno Penzias and Robert Wilson, this radiation is a relic from the early universe. It fills the entire sky and provides a snapshot of the universe when it was just 380,000 years old. This radiation is a faint afterglow of the Big Bang. It is incredibly uniform, but with tiny fluctuations in temperature. These fluctuations are crucial as they give us clues about the early conditions of the universe and how it has evolved over time. It's like a baby picture of the universe, showing us what it looked like shortly after its birth. By studying this baby picture, scientists can learn about the universe's infancy and its subsequent growth. The patterns in this radiation tell us that the universe was once much hotter and denser than it is today, supporting the idea of expansion. These patterns also help scientists understand the distribution of matter in the early universe, which has implications for the formation of galaxies and large-scale structures we see today. The study of cosmic microwave background radiation continues to be a vital area of research, providing insights into the fundamental nature of our universe. Section 8. A universe of possibilities. The idea of a universe that stops expanding is a fascinating thought experiment. It allows us to explore the fundamental laws of physics and imagine how the cosmos might behave under different conditions. While current observations strongly suggest that the universe will continue to expand, exploring these hypothetical scenarios helps us better understand the delicate balance of forces that govern our universe. Section 9. Keep looking up. The universe is full of wonders and mysteries. As we continue to explore the cosmos, we're bound to encounter new surprises and challenges to our understanding. The question of the universe's expansion is just one example of the many puzzles that astronomers and physicists are working to solve.